This is activity 3, making a puzzle from lesson 1, number puzzles. And after having looked at activity 2, which was looking at the temperature puzzle, in which the temperature ended up being 16 degrees, and you had to work your way backwards to figure out that the starting temperature was -7 degrees, and the running puzzle was if Noah ran 1,200 meters in the end, how far did Lynn run? And again, working your way backwards to the distance that Lynn ran, which was ended up being 1,400 meters. So given those two puzzles, what they want you to do now is write your own puzzle of at least 3 steps. And what you're supposed to do is write the puzzle on one sheet of paper, your solution on a separate sheet of paper, give your puzzle to someone else in the class, have them solve it, and see if they solve the puzzle in the same way that you solved it. And you compare notes and talk about it, etc. I would suggest that you take these two puzzles and just change the numbers a little bit and see what happens based on those changes compared to the answer that we got in activity 2. So you're going to investigate these two puzzles rather than write a completely new puzzle. It's sometimes a good idea to just change numbers just a little bit and see what happens. So that's what we're going to do. So in the first case, I'm going to give you some suggestions for both of these. For the temperature puzzle, what happens if you just add 10 degrees to the end? What happens if you add 20 degrees to the end? So work your way backwards, see what the starting temperature is, given that the ending temperature in this case would be 36, or did it end before? Oh, it'd be 26 degrees, given that the ending temperature would now be 26 degrees or 36 degrees if you add 10 or if you add 20 to the 16 degrees. What does the beginning temperature begin? When does the beginning temperature begin as a positive temperature? So in these cases, it begins as a negative temperature. You're going to find that in both of these cases, it begins as a negative temperature. So when does it begin as a positive temperature? What does that ending temperature have to be? At least. And so what happens, so to answer that question, one way to answer that question is to start at 0. So now work your way the other way. Start at 0 and figure out the puzzle if you start at 0 rather than at -7 degrees. And that's going to tell you what the temperature has to be, the minimum temperature that has to be to end up with a starting temperature of 0 degrees. And the first step, if you remember, is to double the beginning temperature. Well, if it's 0, does it make any difference whether you double, triple, multiply by 5, multiply by 1,000? It does not make any difference because all of those multiples of 0 are 0. So what if you add or subtract a value first, then continue with the puzzle? So say you add 5 degrees and then continue with the puzzle. So it's 0 plus 5 degrees is the first step. And then that 5 degrees gets doubled, and then you go through the steps. That is really the same as just starting at 5 degrees. But you can say I'm going to start at 0. The first step is to add 5 degrees. So you're starting to look at different aspects of the puzzle, different ways to think about it. What about the running puzzle? What if Lynn runs 3 times as far as Diego? Or what if Lynn runs 1/3 the distance that Diego runs? So make up 2 puzzles, one in which Lynn runs 3 times as far as Diego, and another one in which Lynn runs 1/3 the distance that Diego runs. What happens to the puzzle then? What if Jada runs 5/4 the distance that Noah runs? So this is an interesting number because this means that Jada will have run farther than Noah. And so how much farther? Well, she's going to run 1/4 of Noah's run farther. So Jada's going to run the distance that Noah ran plus 1/4 of Noah's run. So Jada's going to run 5/4 the distance that Noah runs. And so it begins to force you to work with that fraction a little bit, understand the improper fraction, understand what that relationship is to, in this case, to Noah's run. So you're going to divide Noah's run up into 4 equal parts, and it's 5 times one of those equal parts to get Jada's run. 4 of them will give you Noah's run. All right, so let's take a look at this. Temperature is very cold, so let's change this. Let's just make a simple change the temperature to 26 degrees at the end. And so now you're going to work backwards. So the ending temperature is 26 degrees. So now you're going to, what was the last step to get to that 26 degrees? It was that you added 40 degrees. So now you're going to add that negative 40 degrees. You're going to go back the other way to get back to negative 14 degrees. Before it was a negative 24 degrees. So now you're going to be at a negative 14 degrees. The next step, or the previous step, was to subtract. The temperature became 10 degrees lower, so that would be adding a negative 10 degrees. So now you're going to have to add a positive 10 degrees to go in the opposite direction. And so a negative 14 plus a positive 10 is a negative 4 degrees. And if you remember, the first step was that the temperature is doubled. So now you're going to take half of that negative 4 degrees to get the very first, the starting temperature. So half of a negative 4 is a negative 2. A nice example of what happens when you divide a negative value by a positive value. It remains negative. You're just dividing that negative 4 up into 2 equal parts. Each part is negative 2 degrees. So this is the starting temperature. All right, so it's still negative. So here's the equation that would go along with that. So 2x plus a negative 10 degrees plus a positive 40 degrees equals a positive 26 degrees. So what does x equal? So now to solve for x, you're going to retrace the steps. So you're going to add a negative 40. That would make this go to 0 and this go to negative 14. You're going to add a positive 10. This would go to 0. This would go to a negative 4. And you're going to take half of that to get to 1x. So this becomes a negative 2 on this side. Now what happens if you start at 0 degrees? And so the first step is to double it. So I put, this is the point for each one of the steps. So at 0 degrees, you double that. Well, 2 times 0 is 0 degrees. So now you're still at 0 degrees. And then you add a negative 10 degrees, or it drops by 10 degrees, subtracting 10 degrees, adding a negative 10 degrees. Those are all the same thing. And that's the language that you should use as you go through this to get to develop a level of comfort with working with these, how you state these different equations or these different numbers. So you add a negative 10 degrees. So add a negative 10 degrees, that gets you to negative 10 degrees. And so what was the last step was to add a positive 40 degrees. So you're going to add a positive 40 degrees, and that gets you to a positive 30 degrees. So the starting temperature, if the starting temperature is 0, you end up at a positive 30 degrees. And that makes sense when you look at this. A positive 40 degrees plus a negative 10 degrees is positive 30. So if you have 2x plus 30 equals 30, if you subtract the 30, if you take that 30 away and you take that 30 away, you have 2x equals 0, and then x equals 0. So this makes sense. So you begin to just look at these puzzles algebraically and make some sense of them. That's the whole idea here. All right, what about the running problem? So let's make 2 changes in this problem. Let's say that Lynn ran half as far as Diego. Instead of twice as far, we're going to say that he ran half as far as Diego. And let's say that Jada ran 5/4 the distance that Noah ran. So I like using this improper fraction. This tells you that Jada actually ran farther than Noah. So the information that we have, so we're just going to start out. We know that Lynn ran half the distance that Diego ran. So I'm going to draw an arrow for Lynn. The length of that arrow doesn't really mean anything right now. I'm just using it as a way to begin my thinking through the puzzle. And so that means if Lynn ran half the distance of Diego, that means that Diego ran 2 times the distance of Lynn. And here's an example of using the multiplicative inverse, the reciprocal relationship, or the inverse relationship. If Lynn ran half as far as Diego, that means that Diego ran twice as far as Lynn. So Diego ran twice as far as Lynn, so Diego's out to this point. Then it says that Diego ran 300 meters farther than Jada. So Jada is Diego minus 300. So if Diego ran 300 meters farther, that means that Jada ran 300 meters less than Diego. So Jada now is 300 meters less than Diego, so this length has to be less than Diego's length. And Jada at the same time ran 5/4 the distance that Noah ran. So this length right here is going to be longer than Noah's run. So Noah ran 1,200 or 1,200 meters. And notice that this is also 4/5 the distance that Jada ran. So if Jada ran 5/4 the length that Noah ran, then Noah ran 4/5 the length that Jada ran. It's the reciprocal relationship, the multiplicative inverse. And we'll look at this in a little bit more in just a moment. All right, so working backwards. Noah ran 1,200 meters. So now I am using the units on the grid. Each unit is 100 meters. So this is 1,200 meters. Jada ran 5/4 the distance that Noah ran. So that's 5/4 of Noah's run. So 5/4 of Noah, divide Noah up into 4 equal parts. That's 300 meters per part. But Jada ran 5 of those parts. So 5 times 300 is 1,500 meters. So Jada's out to here now at 1,500 meters. And remember that Diego ran 300 meters farther than Jada. So now Diego is Jada plus 300 meters. So it's 1,500 plus this 300 to 1,800 meters. And Lynn ran half as far as Diego. So it's 1/2 of this 1,800 meters. So half of 1,800 is 900 meters. So Lynn's back to here. So let's look at these equations. So all of this is designed to help students begin to look at symbols in equations as parts of algebra problems to solve, whether you're doing it just in school or you're doing it in your work life as you get older and you have to use some algebra to solve some issue in work. All right, so Jada is 5/4 the length of Noah. So Jada, J equals 5/4 N. So Jada is equal to 5/4 times this 1,200, and Jada is equal to 1,500 meters. So it's 1,200 divided by 4 times 5. So this is 300 times 5. Now notice that Noah is 4/5 the length of Jada. So it's the inverse relationship. And this is just like we used to look at with proportional relationships, and we used to make those tables where the x values on the left, y values are on the right, y is equal to kx. K was the constant of proportionality. And so if you were given x, then you would multiply that by the constant of proportionality to figure out y. Now if you're given y, you would multiply, which would be the y value. If you're given the value on the right, you multiply by the reciprocal or the multiplicative inverse of the constant of proportionality to figure out what x is. It's the same idea. So basically, simply stated, to go the other way, you use the reciprocal. So to go in one direction, we're using the factor that's given. To go in the other direction, we're using the reciprocal of that factor. In this case, the factor or that constant is 5/4. And to go the other direction, you multiply by its reciprocal 4/5. So Noah is 1,200 equals 4/5 of Jada. And so notice when you solve it, you multiply 1,200 by 5/4. 4/5 times 5/4 makes this 1. You're multiplying by the multiplicative inverse to make this 1. which is the definition of a multiplicative inverse. The product of two values that are that have a relationship of being multiplicative inverses is that their product will equal 1. So 4/5 times 5/4 equals 1. And then you have to multiply 1,200 by that 5/4, and that gives you Jada's run of 1,500 meters. So Jada equals 5/4 n. J equals 5/4 n, which means that n will equal 4/5 j. It is this relationship to pay attention to, using the reciprocal relationship to go the other way. You're going to do this a lot as you go forward in math. All right, what about Diego? Diego is equal to Jada plus 300. So Jada we figured out was 1,500 meters plus 300 meters equals 1,800 meters. Now notice that the inverse relationship is that Jada is equal to Diego minus 300. So now this is the additive inverse, or plus a negative 300. Because you're adding 300, you're going to use the additive inverse to go the opposite direction. Down here we were multiplying, so you use the multiplicative inverse. Here we're adding, so you use the additive inverse. So it's Diego, and it might be better to write this as plus a negative 300 to show you that this is the additive inverse of a positive 300, or you can view it as subtracting 300. So Diego is equal to Jada plus 300. Jada is equal to Diego minus 300. And Lynn is 1/2 the length of Diego. So L equals 1/2 D. L equals 1/2 times 1,800. So Lynn is equal to 900 meters. So what's Diego going to be? Diego is going to be twice the distance of Lynn, and that's where we start off over here. If Lynn is 1/2 of Diego, then Diego is twice the distance of Lynn. So Diego's out to here twice as far as Lynn. So if Lynn is equal to 1/2 of Diego, that means that Diego is the multiplicative inverse, because you're multiplying here, 1/2 times D. So the multiplicative inverse of 1/2 is 2. So Diego is equal to twice the length of Lynn ran, or 2L. All right, so how do you write all of this as a single equation? What if that was your task? Write this puzzle out as a single equation. How might you start to do that? I'm just going to say, right, so I know that Lynn is going to be X. She's, or he, is the distance that I want to figure out in the end. How far did Lynn run in the end? So that's going to be my X. And the only number I really know in this, as far as a distance run, is Noah's run of 1,200. So I'm going to just put that in a bracket here. X is not equal to 1,200, but I'm just putting that over here because eventually you're going to have X equals something over here. All right, so what happens to Lynn? Diego is twice the distance of Lynn, so this is going to become Diego. Diego is 2x. And I still don't know what this is over here, so I'm just going to leave this in brackets for a moment over here as 1,200. This is going to get changed pretty soon because we're going to figure out what those amounts should be. But I know that Diego is 2 times Lynn. All right? And so Jada is 2 times Diego. I'm sorry, is Diego minus 300. So Jada is 2 times Lynn minus 300. So we don't know what that equals just yet. So again, I'm just going to put this 1,200 in brackets. And we know that Noah is 4/5 the length that Jada ran. So notice this is the multiplicative inverse. It says in the problem that Jada is 5/4 of Noah's run. So that means that Noah is 4/5 of Jada's run. So we know that Noah's run, and Noah is also 1,200 meters. So we know that 4/5 of Jada's run is equal to Noah's run. So now we have this to an equation that we can use to solve. This is a single equation. When we solve for x, that's going to give us the length that Lynn ran. So now if we work backwards, So now we're going to multiply this by 5/4 to get rid of this 4/5. So Jada is going to be 5/4 of Noah's run. So 5/4 of this is going to give us Jada's run. So 5/4 of 4/5 is 1. So this is going to become 2x minus 300. And 5/4 of 1,200 is 1,500. So we're multiplying. We know that Jada is 5/4 of Noah's run. This is Noah's run. So 5/4 of this amount is 2x minus 300. This becomes 1 right here. We're going to use the multiplicative inverse, and 5/4 of 1,200 is 1,500. And so what happens now is we have to add this 300. So we need to get to Diego's run. So we're going to take Jada and add 300 meters to it. So this is going to become 2x. So 2x minus 300 plus a positive 300 is going to be Diego's run, which is 1,500 meters plus that positive 300 meters. So now we're at 2x equals 1,800 meters. This is Diego, and we know that Lynn ran half that distance. So 1/2 times 2 is 1. So it gets rid of this 2. It calculates to be x. So 1/2 of 2x is just one of those x's. And x is equal to 1/2 of 1,800, or 900 meters. So Lynn's run is 900 meters. So this is to get the problem to a single equation. Kind of tough to do. That will take some practice. I just want to give you an idea of how you might start that. You might practice this with some different puzzles. Just go through it with this puzzle and try to do it on your own without looking at this answer, and then look at this answer and see if you did it right. Use it as a check.